Okay, the last thing I want to talk about is this idea of half-life. Now, half-life literally means how long does it take for half of a radioactive sample to decay. Remember that radioactive decay is a random process, but because there's an equal chance of each individual unstable nucleus breaking down, we can construct graphs to show the rate at which we would expect decay to happen. So on this axis, you will always have a measure of how much radiation remains, starting off here at 100%. The half-life, which is what this axis is on this graph, 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives, and so on. The half-life is the amount of time for the amount of radioactivity to halve. So you can see here the cobalt-60 decay goes from 100% down to 50%, or we could say from 10 grams to 5 grams, and that is 1 half-life. It takes the same amount of time to go from 50% to 25%, or we could say to go from 5 grams to 2.5 grams takes the same amount of time, another half-life. Cobalt-60's half-life is just over 5 years. So you would expect if you had 10 grams of cobalt-60, after 5.27 years, there would only be 5 grams left. After another 5.27 years, or 10.54 years since you started, you would only have 1/4 of your original sample left, or 2.5 grams. So you're definitely going to see lots of variation, but the rules about the graph are the same. Let's look at another one. So on this graph, the amount of radioactivity is measured in counts per second, and the time is in hours. If we were asked to work out the half-life, we'd go to where the line touches the axis here at 70,000, work out half of 70,000, 35,000, and then draw a line to touch the curve, and then vertically down, and where we can read off the half-life. The half-life from this graph is 6 hours. Now we can use half-life for things like dating archaeological finds. One thing that we can use for dating is carbon-14. All living things, or things that were once alive, have carbon in them, and by comparing the count rate of the carbon in an ancient wooden spear shaft that's been dug up with the decay curve for 1 gram of carbon from a modern piece of wood, you can estimate the age. So for example, here this spear shaft is giving us a count of 26 counts per minute per gram. There it is. Take our line across, touch the line, go down to the time axis, and we get an estimate that this spear shaft was made, or the tree that it was made from was cut down 6,500 years ago. So half-life, the amount of time for a radioactive substance to become half as radioactive. That could mean its mass goes down by half, the activity in becquerels goes down by half, the count rate from a Geiger counter goes down by half. Any measure that gives you a quantity of radioactivity, if you cut it in half, we call that 1 half-life. So think after 2 half-lives, you'd have 1/4 remaining. After 3 half-lives, 1/8 remaining. After 4 half-lives, 1/16 of your original sample remaining.